So we're in the molecular simulations starter package. This is the Chemistry with Unity starter scene. We're going to write some scripts. So save as, and I'm calling mine experimenting with scripts. We are going to start from scratch, really. So we'll go ahead and highlight sphere 1, sphere 2, and in the upper right we can just deselect them. Now we can start with a new game object. So now, up at the top, game object. And let's go ahead and make it a 3D object. And sphere. Alright, so it came up as a white sphere. You should know how to change its color, but we're not interested in that. We're interested in making it do something. To make things move in Unity, you want to take advantage of all the built-in physics it has. And that requires this sphere to have what's called a rigid body component. So on the right, at the bottom, it says Add Component. Choose Physics. At this point, choose Rigid Body. Boom. So this is the Unity physics engine. You can see it has mass, drag, angular drag, use gravity. So let's just watch what happens to this sphere. Click play. And it falls because we've checked, scroll down, on the right we've checked use gravity. So this object falls because Unity is calculating gravity acting on the object. If I turn off use gravity, so I'm just deselecting the box, now it will not fall. It's pretty boring. It's not doing anything. If I can check it in mid-play, and there it goes. That's interesting. I unchecked gravity in mid-play. It already had a velocity, and so Unity kept it going in the same velocity. Newton's first law. A body in motion remains in motion until acted upon by an outside force. Okay, so that's your introduction to physics. You've got to have a rigid body component. So this sphere without gravity has nothing to make it move, but we'll now make a script. We'll code its motion. Make sure you've highlighted the sphere in the hierarchy. Then in the lower right, add component. And at the very bottom, say new script. Sphere moving script. I like using this called camel case where there are no spaces, but you can still tell where the words are. Create and add. Click it. Okay, when I did that, my Visual Studio popped up automatically, but I'll go back to Unity, and you can see here it's here. So if I double click that, then I see it's a completely blank script. Let's keep it as simple as it can be. Okay, so start. This will be at the very beginning. What does the object do? So type this, and if you've got the Unity tools installed, it should help you like it's helping me. I want to write get component with these little brackety things. So if it doesn't do it for you, you have to type very carefully. Get component, and then this is the less than symbol, and this is the greater than symbol. And in that space, I type in rigid body. Once again, you see Unity, Visual Studio. Unity Tools for Visual Studio is helping me. Rigidbody. And this is syntax, but you need a pair of parentheses. Okay, so now this is saying access that Rigidbody component on this sphere. And put a period. Let's talk about its velocity. So Unity already knows that velocity is a built-in variable for anything that has a Rigidbody component. Equals. If you remember your physics, velocity is a vector. So I have to type new, and then I have to type vector. So vector 3, you can see it says 3D vectors. Vector 2, 2D vectors. Let's make it vector 2, simpler for you. Okay, vector 2. You can see if I haven't done it right, there's this red squiggly. And if I have done it right, the red squiggly disappears. But it says now I need parentheses. And in those parentheses, I'm going to type the vectors. So if you know the first number I'm typing is the x component of this vector, 5. You can see it's helping me. Float for x. Float means it can have a decimal place, a floating point variable. But I can just type 5. And float y, let's make it 0 to start. We'll change this. We'll play with this. And hit every line in C# ends with a semicolon. And you see there's no little red squigglies. This code is good. In order for it to take effect, I need to save the code. So up here you can see next to sphere moving script CS, that stands for C#, there's this asterisk. It has unsaved changes. So Control S will save those changes, and the asterisk is now gone. This now is going to affect the movement of the white sphere. So I've come back to my scene here, and that sphere has the sphere moving script, and it has a rigid body. So I'm pressing play and hoping that it moves. And there it goes. Boom. So you'll notice it bounced. In this scene, there are walls. So let me stop the motion of the sphere so you can watch what I'm pointing at here. Walls, expand that. There's a right wall, a left wall, an upper wall, a lower wall. And if I click on right wall, on the right, the inspector, it has what's called a box collider, and its material is quite bouncy. This is elastic collision. 100% of the kinetic energy will be conserved. So it should be that my white sphere will bounce between the right wall and the left wall forever. So I just press play again. So Unity takes care of the bouncing. I don't have to write any script. Unity calculates what should the velocity be after this collision. And it as I said, in this case, no kinetic energy is lost. Let's change that. We can do it in mid-flight. This is the right wall that's highlighted. Click the circle with the dot. Go ahead and change it to bounce 0.2. And now watch what happens. See how that bounce was not conserving its kinetic energy. It got much, much slower. So this is tools that are pre-built into Unity. Makes it easier for you to do what you want to do. Stop the motion. Go back to the sphere. Go back to sphere moving script here. We're going to add to this. So right here, before it says start is called before the first frame update. type enter, 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 up, up. Going to create two public variables. So let's say public. Don't have to say variable. We have to say what kind of variable. This will be a float. So that is a number that can have a decimal place. Public float. And let's say x dash velocity. Didn't like that. X underscore velocity. Doesn't like the dash. So there are rules for what you can write in C# and what you can't. Okay, public float x velocity, and then almost the same thing. Public float y underscore velocity. Okay. Then, see, we had typed in, on line 14, we typed in 5 and 0. And that's all that the ball could do, is go to the right and then bounce to the left. But now we can use a variable here. X underscore velocity. You see, Unity's helping me. Or I should say Visual Studio's helping me. It knows that I have such a variable. It helps me type it in without any typos. This should be y velocity. See, there's lots of things I could write, but y velocity is the one I want. Okay. Save this. It is here under the File menu, and it says Control-S. It's just faster to do the keyboard shortcut. Okay, no more asterisk. All right, now let me show you the magic of that. I might have to scroll down to get there. Makes it easier if I minimize this. X velocity, Y velocity now show up as places I can type something in there. So let's say negative 2.6, 2.5, and negative 5. Okay, so now instead of going to the right only, it's going to go at an angle. And it should, these are the components of the vector. Let's watch what happens. So there it is. It goes at that angle. Kind of looks a little like Pong now. That's cool. Did I reset the bounciness of the right wall? Yes. You'll see at the bottom here, the lower wall, I'm on the left, clicking lower wall, is less bouncy. It's 0.6. So let's go ahead and change that. Let's change it permanently. If you change it while you're in play mode, it will revert once you stop the play. So let me stop the play. Let me make the lower wall fully bouncy. So on the right, circle with the dot. Boom. Now it should bounce around forever without slowing down. Let's see if that's true. Looks nice, huh? So now we're going to add a little user interface. So go back to Visual Studio. This is the sphere moving script. And here below update, give yourself a couple of lines, and we're going to create a new function. I'm not going to explain why, but just do what I do. Public void speed boost. Okay, so that's camel case there. No spaces, but you can see there are two words. And at the end of my function, I do need parentheses. So there they are, parentheses. This is going to be a function like update here. You see where it says update with the little parentheses, or start with the little parentheses. So I'm following that same format. And then I need these curly brackets here. So should be able to find it on your keyboard. It's for me it's above enter, and if I hit shift and boom, there I get the curly brackets. think you can also cut and paste. So if you can't find these on your keyboard, let's try it. Control C to copy. Control V to paste. And the red squiggles went away. So yeah, it took all it needed was the characters. It doesn't matter where they came from, keyboard or cut and paste. All right, public void speed boost. This is the key line here that makes the object move. So I'm highlighting that, get component rigid body dot velocity. Copy that, paste that here. Then say equals. I'm going to say 2, and then this asterisk, which is above the 8, is a multiplication in coding. 2 times, and then just paste in 2 times, and then do this again. So I'm copying that rigid body velocity, paste that in, semicolon at the end. Okay, no red squiggles, so it's all good. So what does this mean? It means that the new velocity, the updated velocity, will be twice the old velocity value. And that's a vector. So you can multiply a vector by a scalar. It should double its speed. But we need some way of telling Unity when do you want to double the speed. So here in the update function, I'm going to do an if. If, and then I need parentheses. If what? Input dot get key. I just typed in get k, and you can see I've got 3 choices. I want get key down. If input get key down, and now I need the key code key. So I need to know this is a keyboard command. This is a keyboard command. I have to type my parentheses. I'm typing in the letter A in quotation marks. If input get key down A, and then I need curly brackets because if it's a function that goes, all the steps go in the curly brackets. Okay, if the player types the letter A, that's what the translation of this code is, then let's do a speed boost. And I need the parentheses at the end. Speed boost. Okay, looks pretty simple, I hope. So now we can save this, save the changes, Control S, and go back to Unity. This will often happen where it has to update with the changes in the scripts. Now click play. And type A. A. Boom. A. A. So here's a very simple user interface that's interacting with the script. That looks fun. If I type it again, it may escape the walls. Yeah, so it got too fast. It went through the walls. That can happen. So this is the white sphere. If I highlight it, up here at the top, edit, in the middle, duplicate. Shortcut is Control D. I always use that. It's faster than this menu. But duplicate. And now there is a second copy of the sphere. There will be 2 white spheres. Doesn't look like it because they're right on top of each other. So let me take this second sphere. It's already highlighted. Over here, transform. Says where is it in the scene. Position 2. -2. So this is X and Y coordinates. I just moved sphere 1 here. Alright, but sphere 1 is a duplicate of sphere, and you can see sphere 1 has the sphere moving script, has the rigid body component. Let's make it move in a different initial direction. Sphere 1. So type something different here, type something different here, and then we'll click play and see what happens. They should both respond to the letter A. So let's see if they do. Yep, they do. Okay, and then they can collide with each other. Whoop. And maybe that'll be the next scripting lesson. Will be, let's make something happen when they collide. Oh, there, they collided. But nothing happened. They just bounced off. Boom. Cool.